Welcome back to Class 4, another class where we want to explore bidirectional path tracing. But in this class, we want to focus on connect paths and merge paths. Now, these are two global settings in the bidirectional path tracer in the VCM, but we didn't really touch on those. We used them in the last class, but we focused mainly on the trace light paths in the light. But here we're going to toggle these on and off, explain how they work, show you the differences, because it could get confusing with all these settings. So just a quick review from our last class. If you remember, we took a look at the unidirectional path tracer, which we see in the far left here, and we were playing with allow caustics and thin shadows and stuff. And then we compared those to bidirectional path tracer with the VCM, and we showed that with the trace light paths on and on, it made a big difference depending on our scene, and we set the scene up specifically so we got these really cool hard caustics, these shape caustics through glass, and we needed trace light paths to be on in that. So if we move those over to the side here, we'll take a look at where we're going to go into this class, and let's bring in the global settings for VCM integrator. And here where I've highlighted in yellow, we have connect paths and merge paths. Now in our last class, we kept these on all the time. We didn't want to introduce all those combinations because we wanted to isolate stuff and mainly talk about trace light paths. If we start changing all these settings, it kind of gets crazy. So we kept those on, and we're turning trace light paths on and off, and we showed how by turning them on, not only did it trace the light paths from the light, but it also emitted photons, which got us this really cool stuff. But it also enabled us to take a look at hidden light sources. And the C and the M in the VCM, the bidirectional path tracer, the C is the connect paths and the M is the merge paths, and we showed that in our diagram, and how merge paths worked with caustics and connect paths worked with hidden light sources. So now we want to actually start taking these on and off with trace light paths on and showing you what the differences are there so you get an understanding. And the whole point of this is not only to explain what's going on, but to help you make decisions like, how do I know what, to turn on and off, what's going to save me render time, etc., etc. So let's dive in and take a look at that. So here's a render that we're going to use for this class, and it is our still life, and we want to keep the same scene as we're kind of going through this path tracer bidirectional stuff, just so we sort of see the same results and we iterate on them. So we don't want to switch it up too much, but I like to sort of change it up a little bit. So I've added another piece of geometry. I've added another wine glass, and we have white wine back here. So we're just not drinking red. We've got a nice chilled white, and I've got a sphere light above there. Actually, we'll label the lights, and we'll talk about those in a second. And then we brought the lantern back in, and we've got our chrome sphere geometry that shows off our HDR environment light, which we'll sort of use on and off when we need to. And the denoiser is on in this image, and I've slightly tweaked the sRGB, and it's a little bit more linear in this image. So I've done just a little bit of color correction, just so we can see more of the caustics. If we have the full-blown sRGB, it sort of brightens it up overall. So I just took a little bit down just so we see those nice caustics, and we can see it going through our glass statue here. Really cool caustics happening here. Of course, our wine glass, we've got some extra hits, and we've got this overlapping liquids with our white wine and our red wine, so that's cool. And our usual hard caustics going through the teapot here. And then I like what's going on with the lantern, like coming out here. We've got this just overlapping caustics in here going through the glass, and we see this bouncing light in there. So pretty cool stuff happening. So we've got our VCM integrator. Looking at the labels here, trace light paths are on, connect paths is on, and so is merge paths. And the beauty of the VCM is like these are the default settings out of the gate. So you're not really changing anything. You're just going to the bidirectional path tracer, and boom, this is what you get. Of course, you need to set up your scene with the lights and the materials, which we'll look at in Maya later on. But these are the default settings, so it looks pretty good, I think. What are the lights looking like? So we got 5 lights in the scene, so we've added a few more lights. So what are they? We've got our 2 sphere lights. They're quite bright, and they're sphere lights just above the wine glasses here, and we deliberately put them there to just show off the caustics. So in real life, you wouldn't really have bright dangling light sources above your wine, but you could add some drop down lights if they were actual real lights. But we just wanted to place them there just to show these effects. Then what I did is I put one blue hidden sphere light. So I took this light that we see above the wine glasses, made it a little bit smaller, like half the size, and I just put it inside the teapot below this metallic lid, so it's hidden from the camera. Not only is it hidden by the metallic lid, but also it's in the glass, just to see what our bidirectional path tracer would do. And of course it finds it nicely. And what else? We've got one hidden sphere light, and by hidden we mean it's just behind the glass. And finally we've got one dome HDR light, and I just sort of labeled that here because we're seeing it in the chrome sphere. So we've got 5 lights doing some pretty cool effects here, and these are the defaults of the bidirectional path tracer. So let's dive into what we're going to focus in this class and take a look at some different effects with the connect and merge paths. So here we have that same render, but let's compare it to turning connect paths on and off. That's what we'll do in the first part. So connect paths are on, it's the same render as before, and it really cranked the settings. I wanted to do kind of an overnight long render. It's at 2048 samples, which probably overkill with the denoiser doing a pretty good job. You usually don't have to go up that high, but this scene, we've got a lot of small light sources. It's not your typical scene, and we're going through glass, so I just really wanted to crank it up. But what happens if we turn connect paths off? So let's go into the next render, and we see it gets quite a lot darker, so it's not finding the hidden light sources as well, but the caustics stay the same. And that's because merge paths is what's doing our caustics. We'll see that later on when we look at some diagrams and take a look at merge paths. But if we look at it again, the connect paths going off, look at the render time. It dropped to 2 hours from 8. Again, we could make this way faster with increasing the pixel variance, taking the resolution down, etc. Certainly taking the samples down, but just keep the mind in relatively, because depending on how fast your machines, your render farm, it's that relative scale going from 8 to 2, so that certainly takes down the render time. Doesn't find our hidden light sources as well. And if we take a look at, just go back and forth between connect paths off and on, what are you noticing? Well, the caustics stay the same as we mentioned, but take a look at the light inside the lantern. It's not finding it. It sort of disappears. We can sort of see a faint recollection of it, but take a look at the wine bottles. That completely disappears, the light from inside of the lantern. And then also on our wine here, look at the top of the red wine, that reflection totally disappears. And then overall, it just gets darker and it's not finding those hidden light sources as well. But the caustics stay the same. So that's really important. It keeps your caustics. If you want to keep your caustics, take your render time down, and you don't have a lot of hidden light sources, then you could potentially turn connect paths off. So it just can't find these hidden light sources as well. So let's better illustrate this by going back to our hidden light source. Remember this from last class? We blacked out, this is not glass, we blacked it out. It's totally opaque, and there's only one light source. That's why it's really noisy, and it's hidden. So if we have connect paths on and off, you can't really tell much of a difference here. That's because the samples are fairly low, but it's just really one hidden light source. So what I found in comparing the connect paths algorithm is, let's turn the denoiser off. Let's go to a noisy image. So this is a pretty quick render. It's 6 minutes at 1024 samples, and yes, it's noisy, but I deliberately made it noisy to make the point. With connect paths on, take a look at basically the scene, but look at the wall back here, and it's pretty clean. Now we turn connect paths off. It's 5 minutes, not that much faster. I'm just going to go back and forth for you to see how it just gets noisy everywhere. So this is a better illustration of connect paths, because the caustics stay the same as we saw in the last one. We wanted to show you that. But here, when there's only one hidden light source and we turn connect paths off, just can't find it as well. And the render time's about the same. It's just really noisy because it's that sort of forward path tracing. We'll take a look at the diagrams to show you what's happening there. So if you turn connect paths off, and in the last class we had this, but we always kept connect paths on. We were just playing with trace light paths. Just can't find that light source. So if we go back to our diagram, connect paths is on. Let's move that down here, and let's actually put the render beside here. So we see the C in VCM. Again, saw this in the last class. Connect paths is on. However, what we didn't do in last class, that I showed here, I'm just sort of graying it out a little bit here. So we turn connect paths off, and look how much noisier it gets. So it's not finding the light source. However, we can see by the diagram that trace light paths is on. That's from the light source. We didn't remove that. That means it's still tracing the light path. That's why we still see something. And it gets a little bit confusing because there's a lot of stuff happening here with the bidirectional path tracer. We turn connect paths off, not making that connection. It's still throwing those light paths from the light source individually. We have control over those individually. And if we just toggle back to turning connect paths on, we'll go back and forth, look at the difference and look at the diagram. Making that connect paths really cleans it up in here. Now you might be asking, what happens if you actually turn connect paths and trace light paths off? So now look at this, it's completely black. And this is kind of a cool explanation of it. So again, we're going to go connect paths off, on, so less noisy. But if you turn connect paths and trace light paths off, it goes completely black. So it's still doing the forward tracing paths, but it just can't even find that light source. And if you had trace light paths on, it was noisy, it didn't do that good of a job. But if you turn both those off, remember this is a global setting, connect paths in the VCM. Trace light paths is a per light setting. We talked about that last class in class 3. We never talked about all these different combinations, so we really wanted to show this. Turn both of those off, you get a black image, only if there's a hidden light source. Now, you may be asking, well, what about merge paths? Is that on or off? Well, merge path is still on in our VCM. That's the M in the VCM. However, why does it not make a difference? It doesn't make a difference since there's no caustics in this scene. Remember, the merge path is just for caustics. We'll see more of that later. But it's just a hidden light source. So this is kind of cool because there's so many different combinations you can do here with these concepts. So it gets confusing. But here we can show turn off trace light paths on your light, no connect paths, black image. So I hope that illustrates what these things are doing with respect to connect paths. And then next we'll kind of do the same thing but on the merge paths with our caustics. Let's move on to merge paths. So here's our render again, and we've made it a little smaller resolution, 640 by 480. Kind of darkened it just a little bit. Took out that sRGB curve just so we can really see these effects. And look at the render time, it's 37 minutes, so that's way faster than that original one where I said I cranked it. So you can take that down again, the resolution's down a bit, and I removed the HDR light. So let's turn merge paths on and off, and look at the difference. So now merge paths, that caustics, just we're not getting our caustics. It almost looks like our last class where we took off trace light paths. It's just we're not getting our nice hard caustics. Look at all this good stuff going on here. We just lose it. It's just sort of this almost fake looking caustics. And it takes our render time down a little bit by 21 minutes. Now remember, trace light paths is on for all the lights. So turning off merge paths, it basically is not doing that nice caustics. Even though you're emitting photons from the lights, it's not doing that merge paths to get those nice caustics. So it almost has the same effect as just not even doing trace light paths at all. But this is a global setting in the integrator. So if we look at our graph again, we saw this in the last class, but let's put these new renders right beside it. And so here we see our default settings. Connect paths is on, merge paths, but with all this glass, we're going to look at the merge paths algorithm. And now I've basically, I've just grayed out the merge paths here. So we can see it disappears and we lose our caustics. So again, if we go back and forth, look at the diagram and look at the renders at the same time. So we get rid of that merge paths. It's just basically doing that forward allow caustics path tracing, and we just don't get that nice shaped caustics, but our render time goes down. So this was different than our connect paths that we saw before, because connect paths mainly dealt with hidden light sources. So toggling that on and off in the globals in the integrator, those are the different settings that you get. Related to merge paths and caustics is a thing called merge radius. It used to be called merge radius scale in previous versions of RenderMan when using the VCM, but now it's just called merge radius. So let's take a look at that because it's very related to caustics and merge paths. So here we have our render again, and we've run the denoiser on it. And let's take a look at the caustics, and the best way to explain it really is just to toggle between different scales. So I've pre-rendered those for you, and look at the labels where it's changing the merge radius. So merge radius 1, we'll see where it is in the actual settings in RenderMan for Maya, but this is the default. So just out of the box, it doesn't do any merging as far as the radius scale is concerned. But what happens when we go into 10? Now look under the glasses. Specifically, you can see it there where the wine glasses touch the actual tablecloth. But if we go up to even higher, like a merge radius of 20, you can start seeing more results. So what's happening? It's basically blurring our caustics. So look at this one. We really like this sharp caustics coming out of the teapot on the right of the screen here where my mouse is. So that was nice and sharp. Now if we bring it up to 20, look how it gets blurred. So merge radius is, and we'll see an explanation of this a little bit later from the paper and what it's doing. It's basically blurring the caustics, but I mean, it's kind of complicated because caustics are complicated, so it's not just doing like an overall blur. That's why the render takes, look at the render times now. By default, it's 1 hour and 37 minutes. Again, these are all relative, really depends on what your other settings are. So don't get focused on the render times per se, just the relative nature of them. So this is just over 2 hours if we go up to 10, and then we're at 3 hours for a merge radius of 20. So I'm basically, you know, going from 1 to 10 to 20, and it's significantly taking up the render time. So that's something to note as it blurs our caustics. So where is that in our settings? So I'm going to bring in our integrator and see it there at merge radius. I've highlighted it with the yellow. So by default it's 1, and that's where I'm changing it. So let's take a look at another example in the next slide and sort of explain it from the paper that it was derived from after that. Let's take a look at some other merge radius examples. I did this on another scene with some different settings, but what you can see here is we have the VCM defaults, and let's take a look at this light coming through the sphere, basically some caustics happening, and it's just coming from this area light that's hitting this wall here. And we'll see some different shapes there too, but mainly on the caustics. So if we do our path tracer defaults without caustics, obviously we don't get caustics, but it's a very fast render. And if we do allow caustics, render shoots up, and we start getting some caustics. But what we're really interested in is the VCM. So the merge radius, by default we said it was 1. Like, let's take it up to 20. That render time goes up to 11 minutes. And you're not seeing much of a difference, but if we take that up to 40, we see it starts blurring down here near the sphere, but also against the wall. Look how sharp it was here with the merge radius of 20. But if you look at the VCM defaults, it's really sharp, even up on the wall, which you wouldn't expect because we're looking at usually caustics, but it's just bouncing off a diffuse surface, quite sharp. And now we're starting to blur everywhere, of course, through this glass table as well. And then if we crank it up to 80, render time goes up to 24 minutes, and it's, look at where the sphere is, it's totally blurred as well as against the wall. So you might be thinking, why would we, you know, crank that up? I mean, our render time's going up, and our caustics don't look as cool. It's not as sharp. I can see this blue caustics coming through here as well, kind of bouncing around from the wall. That's cool. Well, I mean, imagine animating a scene, and maybe the caustics, like, you still want them there, but maybe they're just too sharp and they might be flickering, or you might want to not be focused on those caustics. You want them there, but you don't want people looking at them. So you know, you'll bring that merge radius up depending on, you know, what your scene is like. There's no magic number, but the higher you take it, I've been doubling it. It's just gonna blur those more, and of course it comes at a cost, and the render time is gonna go up because it's pretty complex to do this vertex merging. So that's what it looks like. This is just another example scene of what's happening. And if we want to take a look at, now this is not a diagram that I made, I'll show you the paper that it comes from, but it is a paper that the VCM algorithm was based on. So if we took a look at merge radius We can see in this diagram here, as you increase it, it's actually doing the vertex merging, the path reuse, and we can see the renders here and doing unidirectional sampling. This is basically the forward path tracer that we saw in this class and previous ones, and it's quite noisy. But if you do vertex merging, but it's not reusing the path, it's still quite noisy. But look at this. It's doing the merge radius. It reuses the paths and it merges those vertices, and as that merge radius goes up, obviously it includes more of these. That's what, takes a lot longer to render, is depositing. It has to deposit more photons and then merge them together. So that's where the render time goes up, but look how clean it is. So that's kind of a cool diagram from this paper that the VCM was based on. And if you want to pause it here and take a look at some of these URLs, the light transport simulation with vertex connection emerging and a path space extension for robust light transport simulation. I'm not going to repeat that. That's a tongue twister. But here are the links to those papers, and here's a couple more cool diagrams from there. If you're interested in diving more deeper and if you want more math, look those up, and it really describes that vertex merging algorithm and the path connection and the path reuse. So that's pretty cool. That's, fundamentally what the VCM is based on, if you want to go deeper on that and look at more examples. So let's jump into Maya, enough of this theory and slides, and take a look at our scene again. And here we have that different setup. So the camera angle I'm using is here, and we just sort of moved that around and added the stuff to the scene, like the extra wine glasses that I'm talking about. You can see all the lights are red here, and we've also got our dome light. I love this new feature in RenderMan 21 where you can see the dome light there. And yeah, if we poke around, if we take another light source and zoom in on some of the areas here, we can take a look at the actual materials in the scene, because we haven't gone into that and how our materials are set up. We're talking about all the way the light is bouncing, but what are some of the materials that we've set up in the scene? And we're not going to go deep into, in this lesson, on each material, because that's like a whole other class about the glass and metals and refraction. We'll do that much later, but let's give you an overview because we have been using the scene for some time now. So what are we doing for the liquids in the glass? Well, first of all, let's take a look at our RenderMan settings. So if we bring up advanced RenderMan controls and we look at our sampling, we've got our defaults on the integrator, so nothing's changed here. Our merge radius is 1, and our connect and merge paths are on. So if we kick off an IPR render, I always like to kick off an IPR when loading up the Maya scene, just to see what we're getting. Now, of course, this will be normally a longer render, but we just want to see it kick off. And here we can see, obviously it's quite noisy out of the gate. I've pre-saved some of the renders here and I've labeled them. So just like we saw in our slides, we've got our defaults, and I've added sRGB in here, so you see it kind of blows it out a little bit. That's why I made it darker. We can't see the caustics as well, but that's what it looks like by default. And if we turn our connect pass on and off, we already saw what that does. And if we leave our connect pass on and turn merge pass off, we saw what that does. And we get rid of our caustics. But here in our RPR, camera angle is a little bit different, but you can see that it's all working. It just has to take a little bit longer time to resolve. So back to our scene. We can keep that going, or we can just stop the IPR. So back to our scene. So what are we using for some of these things, like the liquid and the glass? I actually did two different things, and again, we'll talk about the materials in deeper on a different class. But in our wine glass, if we bring up our browser, we can see that we have our wine bottle material. And in fact, let's just go, we can see all the materials there, but let's just go in here and let's actually select it. And what I like to do, so that's our wine. And if we go into our node editor and we go on our wine group material and we click on our wine material, this is basically a PXR surface. And we got to give credit to Patrick Hadorn, who set this up from RenderMan 20. And he did a really cool thing, is if you go under the glass setting, and we can see our glass is red, our wine. However, the refraction color is white. So what's happening there? Well, if you go under advanced and under interior, under the extinction, that should be black by default. Look at these crazy values. If you look at RGB between 0 and 1. So the extinction, if you mouse over and look at the tooltip, the extinction coefficient controls how light is absorbed as it travels through the volume. Higher values will block more light. So again, this is a topic for another class, but I just wanted to show you how we're doing it. This gives you more kind of a subsurfacey look to the wine. So to the liquid, it's not like a total clear red. You can play a lot with extinction colors and get some really neat, it's basically simulating a volume. So that's how we're doing our red glass. So you'll notice the diffuse gain is 0 on PXR surface. Primary specular, when you're doing glass, primary specular, just leave it off. I know intuitively you might think, oh, we have specular on refraction, but you go all the way down to your glass settings and you either do the refraction color here, which we could have made red. That's one way to do it. But I wanted to show you this neat way that Patrick, again, set up. And it's doing an extinction, so it gives it a little bit more volume. Now, on the white wine, I wanted to do it the other way. So if we look at our white wine, if we go in here, I'm going to select the white wine. I'm going to sort of expand that at a node editor. You can use a hypershade, but I like this newer node editor. And it's also a PXR surface. And wine white, but notice here, look at the refraction color. So again, our diffuse, 0, primary specular, turn all that off. Just ignore everything in glass. Come right down here. Refraction gain is 1. Reflection gain is 1. Now look at the extinction. It's black. I left that as is because I wanted to make this a little bit different. So all we did is, fairly low roughness, but refraction color is yellowish, and we got our yellow tint from our white wine. It's kind of hard to see because it's behind the camera there. But that is our white wine. And so that's how we're doing our liquids. And let's go back to our render. And if we look at some of the other things in the scene, let's just quickly run through some of the other materials. So our teapot and also our bust has just a basic glass. So let's get rid of this hypershade window just so we have our node editor, and we can leave that up here. And that's a clear glass. And in this case, I'm also using PXR surface, but I'm just leaving the defaults of the refraction color to white. So reflection and refraction gain are 1. So that's pretty simple. You can also use LM glass if you're used to render band 20. That's still supported. And we use a mix and match of the LM materials, but we're mainly using PXR surface because that's the new one. And what about these cool metals? What's going on here? We've got our lantern top. You'll notice that it's got this like brushed steel look to it. It's not really necessary. You can see it here really nicely. But if you want to take a look at that, I just wanted to add that in. And here I'm using actually the old LM metal. So if you look at street lamp metal, you can see we're using PXR LM metal. And then upstream, plugged into the shading tangent, we have our tangent field. And plugged into our input vector, it's a bit of a setup. So they're just in our project directory. If we go into source images, there's NSO vecircles.tex. And for some reason, they're not coming up in the preview here, so I'll just drag and drop them into our in window. I don't know if you knew you could do that, but I'm going to grab these for these ship with RenderMan. These are pretty cool textures for shading tangents, so we can just drop those in. And that's basically what they look like, and you'll notice that they're all just a red and green channel. So if I go red channel, I'm pressing the S in it, or the green channel, there's nothing in the blue because it's a shading tangent direction. So it's just the red and the green talk about your U and your V direction for the shading tangent. Again, a lot more there to discuss in another class about materials, but just to give an overview, that's what it looks like for that cool kind of brushed metal on the lantern. And we've got our wine bottles, which just have some green glass. So what does that look like? Well, in this case, I did a PXR layer surface, which enables you to layer the materials. And I love the PXR layer surface because the base layer just has our globals. So these are non-layerable. And if we go upstream, we have our layer mixer and our layer 1. We can see our glass is not enabled, but our base layer glass is enabled, and there we have the refraction color of green. So why do we have two layers? Well, if we look at our diffuse, we've got our red color. What's that? Mask. And that's the top part of our wine bottles there. So we've got green glass, refraction is green, and then we just have that red for the label. So that's a cool kind of two-layer label on top of glass. And finally, our tablecloth is just basic gray. What about our metals? We've got a bunch of different metals in here, like the rings and the top of the teapot. That's going to be, if we select our metal rings or the top of our teapot, one of them I'm using LM metal, and one of them are using our PX surface. So PXR surface, so glass is not on. But if we just look into our primary specular, it's changed to physical. And what's this blue or like refraction index? That doesn't seem typical for gold, but actually the refractive index of complex metals, again, this is going to be a different class, is going to define silver, gold, and all the different metals. If you want to look at the other ring to see the presets, I'm going to select the other ring, and ring 2 actually has ring silver, but I've used LM metal in this case to demo the presets. If you look at presets button, look under gold, replace, that'll show you that refractive index, which is similar to what we saw on PXR surface where it's blue. It'll actually change the refractive index for different metals. So if we went to copper, see how that totally changes? Mercury. So it's just changing that refractive index and extinction coefficient. So we'll talk about that in like an advanced class on materials and metals. But again, just to give you a little overview. So let's change it back to gold. LM metal, also in PX surface, we're doing metals. And then finally on our lantern, we've got our yellow sort of glass. So what does that look like? So I'm also using a layer surface on that. And upstream, if you look at the glass, I've enabled it, and all I've done is I've changed the refraction color to sort of gold tint, and everything else is off. So similar to our other glass there. So that's an overview of the materials in the scene that we're using. And all our changes mainly in these classes, because we're keeping the materials are the same, is under Advanced RenderMan Controls, under the sampling, and we're just playing with all the different settings here. I've highlighted some of them by just making keyframes just to change the colors, because we've changed the merge radius, played around with photon guiding. I didn't show that yet, but that's something else you might want to play with, and the light and BXDF samples, which significantly take up the render time in our case, just to do a little bit more sampling on the BXDF and lights. But that's not something that we talk about in this class, but that's again something you can play with in the VCM. But mainly we're taking, the 4 settings, turning connect paths and merge paths on and off, doing just connect paths, no merge paths, and vice versa. So we have the 4 different settings that we have there. And then remember, in our lights under advanced, we can turn off and on trace light paths and thin shadows. So that's mainly what we've been looking at in this class, and showing the different renderings results. So not too many different things you have to change in the VCM, and that's the beauty of it. There's just a few toggles there, but we really make some drastic changes, so we really wanted to explain those in here. And then we'll dive further into all the different material settings you can do in different classes. So play around with those different settings, play with the different materials. Of course, if you change mainly the roughness on a lot of these glass materials, because we're doing a lot of glass, then you're going to get a lot different results. With these caustics, it's going to be a lot more blurry. I've deliberately kept them clear. So a lot of different things to play with these scene files. And that's an overview of how it looks like in Maya for this class. So if we were to summarize a number of the topics, because the last 2 classes we talked about a lot of different combinations with the bidirectional path tracer, with our trace light paths per light, and our global merge and connect path settings, and all the combinations. So might be a good time to summarize some of the stuff. And again, this is all with the VCM, the bidirectional path tracer. So What do we know from the last couple classes about our trace light paths? Well, those are set per light, and that gives you that artistic control, which is really cool. And the trace light paths, even though you see the user interface, the UI in Maya and whatever bridge product you're using, Houdini, Katana, etc., it's usually always in the light, but it only applies to the VCM. So if you're using the path tracer, the unidirectional path tracer like we used in class 2, trace light paths doesn't do anything, and it says that on the tooltip. So remember, this is just for the VCM integrator. It's a per light setting, gives you artistic control, which is really cool. We saw that in the last class. We can turn it on and off on like the HDR map, but keep it on our other light sources. So that's pretty cool. And when you turn that on, it turns a couple things on at the same time, the light and photon path. So those are two different things. You could, in theory, and in other implementations, just turn on photons from that trace light paths from that light, but not the light. But in our case, it turns on light and photon paths. And for the light paths, as we saw, it does a really good job finding hidden light sources when you have trace light paths on with hidden light sources. And the photon aspect of it is really good for caustics. We saw the merge radius scale when we have our caustics on or off. Like in this case, we turn merge radius off. The trace light paths, the photons are great for caustics. Now connect paths, so this is a global setting in our integrator. It's not on the lights. And the connect paths is really good for hidden light sources. And if we have connect paths off and merge paths off, it's not really doing bidirectional path tracing because it's not finding any of those lights. But if we turn it off, as we saw here, when we turn the connect paths and the trace light paths on the light, we get completely black. But if you just turn connect paths on and off, it doesn't really affect the caustics we saw. We saw it kind of just a hidden light source of the light bouncing around in there, especially in this scene. And the merge paths, again, just like the connect paths, they're global in the VCM. These are really good for caustics, and we saw them in the last class, a combination of trace light paths with merge paths, but now we separated them out and we just called merge paths, and we saw that the caustics just really didn't, we didn't get those sharp caustics. So it doesn't really affect our hidden lights, it's mainly our caustics. So that's a summary of all the different combinations with these three features, both in the lights and the integrator, and mixing and match between them all. So of course, take these concepts and apply them to your scene. There's like so many different scenes you can apply these to and do some cool hidden light sources and some architecture interior renders, or have some more glass renders. But hopefully that gives you a better understanding of not only what it does, but like when you make decisions of what you want to turn on and off. Because as we saw, if everything is on, the render takes longer. If you're not doing a lot of caustics, maybe either take trace light paths off those lights, or you can disconnect, you can turn merge paths off. You'll get faster renders. If you don't have a lot of caustics, just hidden light sources, that'll work for you. So hopefully that helps you in your scenes and making decisions on which of these features to turn on or off.